For this energy problem, we have a spring here. And at A, the velocity is 0, so we have V naught written as 0. And we're to find the velocity at B once the spring has moved, or once the slider has moved from A to B. And we're ignoring friction here, so we can assume that mu equals 0. We've been dealing with the kinetic energy and the potential energy of gravity, but now we're also going to be looking at the potential energy of the spring. So other than that added equation, everything here is very similar to what you've done in the last homework section. So looking at the change in kinetic energy, you have 1/2 the mass of the slider, which is 3, times v squared minus 0. And for potential energy, the radius is going to be the vertical height. So it's moved downward, so that'll be negative 9.81 for gravity times that total distance, which is 0.8. Now for the spring, it's going to be a little bit of a long equation because we have to deal with the difference from the spring at resting. So if this is the spring resting, which is that 0.4 meters, we need the distance from there. So we have 1/2 and the k is 200, so times k. Then we multiply it times that difference. And for us, that is going to be the square root of 0.8 squared plus 0.6 squared minus a 0.4, and that is all squared, minus the difference from the resting, which is 0.8 minus 0.4 squared. And this is the change from the resting and the change from the initial and final position. And once we solve for each of those, that is equal to 3/2 times velocity squared, and this is negative 23.5 joules, and the potential energy of the spring is 20 joules. So if we looked at that equation in terms of it all equaling 0, we get the change in kinetic energy plus the change in potential energy due to gravity plus the change in potential energy due to the spring. All of that equals 0. So let's plug in what we solved here, here, and here, and we can simply solve for the velocity. So that is 3/2 velocity squared minus 23.5 joules plus 20 joules. And in the end, our velocity is 1.537 meters per second. And that is the final velocity at B, because we have that spring that's adding on to the potential energy.